Hello friends, welcome to G-Centric. So in today's lecture we will see about the concept of leading and lagging. So in the word itself you see that there is a lead and there is a lag. Okay, so lead means it's something which is front. Okay, so lagging means something which is behind. Okay, now when something is behind and something is leading, that means that we are going to have some reference point with some other object. Okay, so you can only then say that this object is leading than that object, or that person is ahead of another person. Okay, similarly for lagging also you have to get two quantities to compare whether it is lagging or leading. You have to have at least two quantities to compare for the lagging and leading, otherwise you cannot understand this concept. Okay, so basically this concept will be invalid if there are no more than two quantities. Okay, so now in this network theory, to get the and to understand the concept of leading and lagging, there are three main points. Okay, so first one is that, so basically we will be using sinusoidal waves. What type of waves? Sinusoid waves, signals. Okay, so these will be using for the concept of leading and lagging, and to understand this we have got three main points. There are some rules to form the leading with two signals. Okay, with two sinusoidal signals of waves. So first thing is that both the sinusoids, so both the sinusoid should have same frequency. What is the frequency here? It is omega, angular frequency, which is measured in radian per second. Okay, then our second point is that both the sinusoids must be either in terms of sine or cosine. Okay, so when you are comparing two sinusoids, it must be either in the terms of cosine or it must be in the terms of sine. If it is in cosine and if one signal is in cosine and the other one is in sine, then we have to convert it into same quantity, either sine or cosine. Okay, so that is the second rule. The third rule is that both of the sinusoids must have positive magnitude. Okay, so this must have positive magnitude. Suppose if you have got Vm is equal to Vm sin omega t, so this value must be positive always. So if in any of these three rules, if the signals does not satisfy any of these three rules, then this concept fails. Okay, then we cannot apply. Okay, we have to compare the quantities which have the same value. Okay, you cannot compare kg to kilometer, you cannot compare kg to grams. Okay, there will be some conversions. If there is same quantities with same reference, then we can use this leading and lagging concept. So if you take the example of sports, if it's in a weightlifting, then if you are in 50 kg category, then you cannot go and compete in the 70 kg category. You have to compete with the same weight category. Okay, so that is the meaning of all these three. So for comparing two quantities, we must have the same reference. Okay, same work must be done. Now after this we will move on to the graphs. How we can do this, compare these quantities using graph. So we will take three cases. Okay, so case 1. So now there are two signals. We will take two voltage signals as our reference. So let one be VA. Okay, so this is VA of t. Okay, for that instant of time we are taking, that is why we will write it as t. It is having Vm sin omega t. Okay, so I will draw this one. If I take the y axis for V of t and this is omega t, time axis. Okay, I'll draw the sine wave. Okay, so this is the sine wave which has got the peak value as Vm. Okay, now this is nothing but representing the Va of t. Okay, now there is one more signal, Vb of t. Okay, so what does Vb of t? It will not start from origin. Okay, so always sine wave starts from origin and cosine does not start from origin. Okay, so if this Vb of t is not starting from origin, but after some time, say from this point, this wave is moving in the sinusoidal fashion. So now if it is starting point is this, then here also it has to be there must be some gap. Again here also there must be some gap. So if I start moving in this way, drawing this, okay, it will go on like this. Now both of them will be having same magnitude. Okay, for the first time we will take the same magnitude, that is peak value will be Vm. Okay, so now how do you write this one? What is this gap called as? Nothing but phi. Okay, this gap is called as phi. So to write this Vb of t, I will write Vm sine of omega t. Now whether it will be plus phi or minus phi. So to understand that case, it is definitely minus phi. So to understand why it is minus phi, we will take the example of two friends. Okay, so if A and B are friends, okay, if A is one person, B is one person, they have to go to the office for the work, then A will leave early. Okay, it will wait for B, but B does not come on time, so A will leave early. So this black line indicates the movement of the A person. Okay, then B after some time B will start moving it from this point. Okay, so now this B will move in this direction, A will move in this direction. So which is the first person that reaches the office? It is A, because A has left earlier than B. Now if you see in this graph, you will assume that B is is ahead of A, but since this is the time axis, A is starting early than B. Okay, so what we can say is that this is the voltage waveform of Vb of t. What we can say from this waveform is that Vb lags Va by phi degree. Okay, so this angle is always measured in degrees. Okay, or you can also say Va leads Vb by phi degrees. Okay, so this is case number 1. So next, if you take, I'll rub this one. So now if you see both of them have got same frequency, that is omega t and omega t, and both the values are having positive, plus and plus, and both are in the terms of sine. Okay, so all the three are satisfied, all the three conditions are satisfied. That is why we can apply this concept. Okay, now coming to the case number 2. Now in this case, B leaves early to office than A. So what happens, how this graph will look is, if I draw case 2, if this is voltage and this is omega t. Okay, this is omega t. Now what B will do is that, since it has left late yesterday, he will move early. He will leave early to the office. Okay, now as usual, this is the signal of Vb. Okay, they have the magnitude Vm, since we are taking the magnitude as same Vm. Now A will leave as usual, it starts from here, goes here, it will move on. Okay, so this is the signal of Va. Now what happened, B left earlier than Va. Okay, so now what happens here, Vb leads Va by, so what is this gap from here to here? It is phi by 5 degrees. Okay, or you can tell on the time axis, if you stand here and see, okay, if you stand here and see, you say that Va lags VB by 5 degrees. Okay, because since it is the time axis, whichever signal is first, okay, whichever signal is first than the other, that will be ahead, that is leading. Okay, if you see a signal here, then if you see a signal here, this will always, the second signal is lagging than VB. So how do you write the equation for this one? Okay, this is VA will remain as it is, VA of t will be Vm sin omega t. Since B has left early, we will write the equation as Vm sin of omega t plus 5. Okay, this we will call as advance because it's early. Okay, this is advance. Then this we will call it as delay. Okay, so we will keep one reference. Okay, so in this case we will keep VB as the VA as the reference, and we will see what is the position of VB. So here VB lags VA by 5 degrees, and here VB leads VA by 5 degrees. So this is the case number 2. Next, coming to the case number 3. Okay, so we can draw this one. So first A left early, then B left early. Now both of them decide to leave at the same time. Okay, so this is V of t, this is omega t. Now this is signal of VA, and here at the same time they are going to leave. Okay, so this, since their magnitude are same, it will be overlapping each other. Okay, so red indicates VB and green indicates VA. So in this case, what we will tell, VA and VB are in phase with each other. Okay, so they are in phase with each other. So there is no lag between them. So what will be the equations? VA of t will be Vm sin omega t, then VB of t will be also Vm sin omega t, and 0 degrees lag or lead. Okay, so they are in phase, in same phase, or we can just say they are in phase. So the equation, these are the 3 cases, case 1, case 2 and case 3. So in this case, if something is first, whichever signal appears first, that will be leading. So whichever second is there, here given one, that will be lagging with the other signal. Okay, so this we have taken as voltage as reference. You can take even current as the reference. Same concept will be applied for both of them. Now we will move on to the sinusoidal and basic trigonometry. Okay, so before that we will understand what each of these terms mean. Okay, so let me rub this one completely. Okay, coming to this one, we will take a waveform. Okay, so let this be, okay, we will tell it as V of t. Okay, and here this is the omega t axis. Okay, now we will take one signal. We will take a signal, sinusoidal signal. Okay, let this be VA and this be Vm, and here they have the same peak, that's why this is minus Vm. Okay, so now what we can write for this signal, equation is VA of t is equal to Vm sin omega t. Now we will take each of the individual terms and analyze what do they significance, what the significance is there in this graph. Now first one is, we will take VA of t. So now what does this t indicates here? Instantaneous value. If you put at time t is equal to 1, then here also if we substitute t is equal to 1, at that instant we are going to get this value, that is the voltage value. So what we will call this as, we will call this as instantaneous value. So VA of t is nothing but instantaneous value. Okay, so this is the significance of VA of t. Coming to the second one, so what do we have? VM. So this term VM. So what does this indicate? Here is in this graph you can see VM is here. So what is this? Nothing but the maximum, or we can tell peak value. So this, since we have taken V of t, it is called as maximum voltage or peak voltage. If it is current, we will say peak current or maximum current. Okay, so this is over. Then what is this omega? Okay, third one is omega. We will call it as angular frequency. Okay, so there is a relation between normal frequency and angular frequency. Okay, so basically this angular frequency is measured in radian per second. Okay, so what is the relation between this angular frequency and normal frequency is 2 pi f. Okay, so this is measured in radians per second and this is measured in hertz. Okay, so this is the frequency, normal frequency, and this is the omega. So this frequency has got one more equation, that is 1 over time period. So what is this time period mean? It is nothing but the fundamental, we will call it as fundamental time period also. It means that after some time this cycle will repeat again. Okay, so basically after this there is some certain time, after that this cycles goes on repeating. So frequency is also cycles per second, but here you can see we will call fundamental because only for that period of time this cycle is repeated, and for the second period of time same cycle is repeated, but it will not be the fundamental. Okay, so the fundamental, this time period, whole thing repetition up to here, we will call it as one time period. Okay, repetition of the cycles. Okay, so this is about the time, so frequency and omega. So this omega t, fourth one is omega t, it is called as argument. Okay, here it is called as argument. Now we are left with one more thing, that is fifth one. Okay, so from here to here, plus Vm to minus Vm, we will call as peak to peak value. Okay, from plus that will become 2 Vm. So we will not consider this negative sign, we will only consider the magnitude. So from here to here it is 2 Vm, it is nothing but peak to peak value. If it was current, then we would take 2 Im. Okay. So now what is the link between current, electrical energy and mechanical energy? Okay, if you take a generator, this is a generator. So we get electricity from the generating plants or alternator or synchronous generator. Okay. Now for this one, here will be some turbine and the turbine has got shaft. Okay. So this shaft will help drive this generator. It has got some speed at which it rotates, and it gives us electrical energy. So here it is mechanical energy. So when mechanical energy is converted to electrical energy, we call it as generator or alternator. So this, if it is rotating at certain speed, we will call it as RPM. Okay. So this RPM is connected to electrical energy and the frequency with the formula called synchronous speed. This RPM is denoted as synchronous speed, 120 into frequency upon P. Okay. So this is the formula for the frequency and mechanical energy, synchronous speed with the rotation. Okay. So this P is nothing but the number of poles. So this is very helpful formula, and most of the time we use it in the machines. Okay. So in the machines we can see how this formula is derived. So this is about the basic sinusoidal wave and their terms introduced. Okay. In the next lecture we will use the trigonometry, and we will see some of the formulas related to the trigonometry. Okay, so if what is cos omega t plus 90, how did we get that and all, we will see in the next lecture. Okay, thank you.